Welcome to time value of money, a fundamental topic in corporate finance that basically looks at how to equate time for money. So in this course, we're going to look at key principles that pertain to evaluating how much an investment now, which we call a principal, will grow into a future value tomorrow. So if you're asked how much would you rather pick, 1,000 today or 1,000 tomorrow, definitely would pick 1,000 today. Simple reason being that 1,000 now is not susceptible to interest rates. So in time value of money, we're also going to look at compound interest, which looks at how an amount that has been compounded either annually, semi-annually, would be tomorrow. So interest can either be earned or accrued. So we have different types of interest. We have real interest rates, nominal interest rates, and inflation is an interest rate that devalues time. So by the end of this session, you must be able to understand time value of money in terms of future value and present value. And I'll just go up until annuities. That's all. So time is money. And for that very fact, you're spending time in this course with me. And so we're going to look at these types of interest rates that are very pertinent: simple interest, compound interest, and also we're going to understand what loan amortization is all about. So from your own basic definition, what do you think interest is? What do you think interest is? Or what an interest rate is? So interest rates are very fundamental in finance because they look at the cost of borrowing. So interest is simply cost of borrowing. The different types of interest would be compound interest and simple interest. So let's look at these ones at length and apply them in this course that we are about to start. So when we're dealing with simple interest, basically, we're looking at the calculation of a percentage on the principal amount that was invested. The formula is given by simple interest is the principal times interest rate and time. And this time is usually expressed in years, unless otherwise stated. So the time being expressed in years has an annual compounding, which is once. If we are looking at a semi-annual, meaning we are earning interest twice. We're looking at a quarterly basis, we're earning interest 4 times. Monthly, there are 12 months in a year. Weekly, there are 52 weeks in a year. Daily, there are 600 and what? 365. So for that very fact, you need to know that the interest rate should always be divided by the number of compoundings, which we have as 1, 2, 4, 12, and 52. And the time is always multiplied by the number of compoundings. Compound interest, on the other hand, takes what we call a geometric progression, where the principal amount plus the interest accumulated from the previous period is calculated. So we want to calculate the interest rate based on the accumulated value. So we're going to look at a few examples. Any questions so far? So when you're given information like this, the principal is 1,000 at an interest rate of 8% for 5 years. Find the simple interest. So the principal is 1,000. The time is what? 5 years. Then you have what? Interest rate is 8%. So what is our simple interest we're going to earn on this? So we're going to have a 400 kwacha. So meaning after 5 years, the total value we're going to have is called the future value. The future value after 5 years under simple interest will be the 1,000 we started with plus the 400 kwacha that we have, and we get a simple interest of 1,400. All right. Compound interest, on the other hand, is calculated by finding the difference between the future value and the present value that we started with. Now, the future value in this case is present value, which is the principal, 1 plus r to the power time. So what is our principal that we are starting with in this case? The 1,000 kwacha. And what is our interest rate? It is 8%, which is 0.08. The time that we have here is how many years? 5 years. In this case, we're going to have 1,000, then 1.08 to the power 5. So we're going to get our future value. So what's the future value in this case? And on the calculator, future value will be what? And on the calculator, what are you getting? Okay. So in the event that we have compoundings more than once, sometimes the formula will be given as a present value, 1 plus r to the power time. So here would be told the same question that it's compounded annually or semi-annually. So it will change the narrative. So here, we only use this formula when the compounding is what? Done annually. So the more you compound, the higher the figure. So here, the power 5 times 1,000, we're going to get what? 1469 point what? 0.33. But if it's compounded more than once, we're going to have this scenario. Our present value is 1,000. Our interest rate is 8%. And our time is 5 years. But in this case, we've been told that it's compounded quarterly. Quarterly means m is equal to 4. So here we're going to have 1 plus 8%, which is 0.08, over what? Our m, which is 4. And here we multiply this by what? Years. So here we're going to have 1,000, 1.02 to the power 20. So our interest rate will now be 1.02 power 20 times 1,000, which will give us 1485.95. So we have an interest, compound interest, which is the difference between how much we started with and how much we have. So 1485.95 minus 1,000. What do we get? 485.95. So this is exactly what we have here. That is our interest that we've accrued. So this component here gives us a new concept that we have, which is called the effective annual rate. The effective annual rate is simply given by 1 plus R over M minus 1. So if we're told that our interest rate is what? 4%, for instance, and it's compounded annually, it's compounded quarterly and semi-annually. Semi-annual and quarterly. And they asked us to calculate what we call the effective annual rate. So part A, semi-annually, we know that our aim is what? 2. Quarterly, our aim is what? 4. So we want to see which one will give us an effective annual rate which is higher. So part A, we're going to have 1. The interest rate is 12%. Then the compounding is 2. So take note here, the time aspect is not included. That's a mistake people make. So the questions sometimes may be confusing. They'll put time there that we're not using here. The second part, the only difference here is that it's compounded what? Quarterly. So here we're going to put 4 and minus 1. But for the first one, you have 1.06 to the power 2 minus 1. So here we're going to have 12.36%. And here we're going to have 1.03 to the power 4 minus 1. What are you getting there? So you can see that the higher you compound, the more the effective annual rate. Okay, now what is this very effective annual rate? What does it stand for? What is an effective annual rate? This effective annual rate is used in banks. It is used whenever you're compounding more than once. So it is also called the annual equivalent rate or the annual percentage yield. It represents the true annual interest that is earned or paid in an investment when compounding is taking place. So it's important that we understand this concept because it carries about 6 marks sometimes when we are given as an example in an exam setup. So effective annual rate simply is defined as follows. It is the true interest rate which is earned or paid on an investment when compounding is taking place. So it is given by 1 plus the nominal interest rate over n minus 1. So this is how we find the effective annual rate. Now, time value of money can also twist sides. You'll be given the present value as 1,000, the future value as 3,000, and you're given the rate as 8% compounded annually. And you're asked to find the time. What is the time? So the formula for future value is what? Present value, 1 plus R to the power what? Time. So in this case, our future value was 3,000. Our present value is 1,000. Our interest rate is 8%. And our time we do not know. So when you divide this and that, we're going to have what? 3. So the only way we can find our time there is by introducing logs. So log 3 is equal to log 1.08 to the power time. So the log is the only function that makes the t drop down there. It would be t times log 1.08. So to find our t, we divide both sides by what? Log 1.08. So LG or log, just the same thing. Don't get confused. You punch on a calculator and divide log 3 divided by log 1.08. It will give you log 3 divided by log 1.08 will give you 14.27 years. So that's how long it would take for 1,000 kwacha to triple. Sometimes they not give you this 3,000, just say how long will a value triple at a rate of 8% compounded annually. How long means time. Also, the same question, the present value, they could give you 1,000 kwacha. The future value, they could give you maybe 2,000 kwacha. And the time, they would give you maybe 4 years. They'll ask you what rate will cause a value to what? Double. So remember, future value is equal to present value, 1 plus r to the power time. So here we have 2,000, and here we have 1,000, and here we're going to calculate the right rate, which we do not know, the time is 4. So this will give us a 2. So here 1 plus r to the power 4. There's an invisible one there. What happens here is that you find the reciprocal. We have to get rid of what? The brackets. So times 1 over 4. 1 over 4 is the same as 0.25. So here 2 to the power 0.25. And here it cancels. We're going to remain with 1 plus r. So to find our r, we simply 0.25. Or if you want 2 to the power 1 over 4, it's the same thing. But it's easier to work with the what? The fractions. So if you go to your calculator, 2 to the power 0.25, we're going to get 0.1892. This is the same as what? 18.92%. 18.92%. So this is our interest rate. This is our interest rate. So we're just twisting the same formula, which is done in different ways. Now, we could also have a series of payments that are made regularly. Those payments are called annuities. Okay. So annuities are a series of equal payments. These payments are made either at the beginning of the period or at the end of the period. The beginning of the period or at the end of the period. So if we have a beginning value that is made, it's called an annuity due. If we have at the end of the period, we call it what? An ordinary annuity. So annuities can come in different forms. Well, what is called the present value of an annuity, well, what we call the future value of an annuity. These are called ordinary annuities, so they're made at the end of the period. So we have examples of annuities, rentals, insurance premiums. These are all annuities. But if they're made at the beginning of the period, we just multiply the answers 1 plus r, multiply them. So it will be called an annuity due. So the formulas for annuities, for instance, present value of an annuity is simply the payment that you have, 1 minus 1 plus r to the power time negative over the interest rate. Then for it to become annuity due, the present value of an annuity due, it is simply the present value of an ordinary annuity multiplied by 1 plus r. But if we're dealing with future value of an annuity, it is simply the periodic payment that you're going to have. Then we're going to have 1 plus r to the power positive t minus 1 over r. This is when it's made at the end of the period. But for it to become a future value annuity due, just compute the future value of an annuity multiplied by 1 plus r. So you'll be given For instance, a payment that is made regularly of 1,000 kwacha at an interest rate of 10% for a period of 3 years. So you're asked to find these 5 things. Number 1, find the present value of an annuity. So remember, the formula is the payment plus the present value, interest annuity factor, the rate against time. This one will be given tables, but I prefer that you use my formulas. So the formula that I gave you was what? 1 minus 1 plus R. Our interest rate is what? 10%. Then over the time divided by the interest rate. So here when you compute, we're going to have 1,000. Then here we're going to have 2.487. So this one is the same as what? 2,487. That is the amount that we have at present value annuity. Okay. So maybe let me take you through the financial tables. Sometimes it will be important that you understand how to get this from the financial table. Suppose you don't have to remember the formula. So here I said the percentage is 10% and the time is 3 years. So you go into the financial table under present value annuity, ordinary annuity. So 10% and under year 3. 1, 2, 3, you find 2.487. So just put it there. So all this is 2.487. Multiply by what? 1,000. You get this figure there. But if you want to call it an annuity, you just multiply. You just multiply your answer here. 248.7 times 1 plus R. R is 10%. So 24.87 times 1.10. So we get what? 27.85.7. So this is what is called the present value annuity Q. The future value of an annuity is an amount we expect in the future. Present value is the amount we're expecting now. So to illustrate that also under present value annuity, we're talking about you have 1,000 kwacha that you expect in year 1, in year 2, and in year 3. But you want it now. So many, because of inflation, the amount you're going to get will be less. So we go to the interest rate. So here we're going to divide this one over 1.10 to the power 1. Here 1,000 over 1.10 to the power 2. Here 1,000 over 1.10 to the power 3. So when you get these present values here, 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 the total is what we are getting as 24.87. It's called an annuity present value. If you're taking it forward, it is a future value. 0, 1, 2, 3. You're getting 1,000 here, 1,000 here, 1,000 here. Of course, this one will not stay because these are end period. So here is simply 1.10 to the power 0. It doesn't stay in, it will still remain 1,000 kwacha. This one will stay in 1 year until the following year, 1.10 to the power 1. You're going to get 1,100. This one will stay how many years up to year 3? 2 years. 1.10 to the power 2. So here you're going to get 121, 0. So the total that you're going to get here is 3310. So this is what we call our future value of an annuity. So when you want to get the future value of an annuity due, you simply have 3310, 1.10. 310, why are we getting the 1.10? Because the interest rate is what? 10%. If it was 8%, I'll put 1.08. Okay. So here, that's what we're going to get as 3641. So this is using the number line. But if you're using the formula that I gave you, future value for an annuity, simply the payment Then here we have 1 plus r to the power time. And that's 1 over the interest rate. So in this case, our payment is 1,000. And here we're going to have 1.10 to the power 3x over the interest rate of 10%. So in this case, when you compute that, we're going to get our interest factor annuity as the 3.310. So which will give you the 310. All right. That is called our future value of an annuity. So whenever you hear periodic payments that are fixed, that is called our future value. So when you want to get our future value annuity due, just multiply the answer that we got here, times 1 plus r. So we're going to get 3641. So I'll send you homework based on what we've covered now. Unless any questions, you can ask now. So in the evening, we're going to look at amortization. Then we go to bond valuation and stock valuation. Thank you so much for your time.